a retired U.S. Navy admiral, believes that the government should look to the oceans to help solve a mystery in the skies. Rear Admiral Timothy Gallaudet, former oceanographer of the U.S. Navy, cited a 2019 sighting by a Navy warship as evidence that the phenomena of UFOs and USOs are linked. The sighting, recorded off the coast of San Diego, involved a hovering spherical object that appeared to abruptly enter the water. Gallaudet made the case for studying underwater UFOs, or what the government calls UAPs, in a recent paper titled "Beneath the Surface: We May Learn More About UAP by Looking in the Ocean." Gallaudet writes that transmedium USOs and UAPs, defined as unidentified objects that appear to travel both in the atmosphere and the water, jeopardize U.S. maritime security. The retired Rear Admiral makes the case that the undersurveyed underwater realm is a threat to maritime security. The oceans form the bedrock of international trade and the American economy, and are where the U.S. Navy operates. The retired U.S. Navy admiral argues that the lack of knowledge about the undersea world poses hazards for submarines, such as collisions with other submarines, such as the independent crashes of the submarines USS San Francisco and USS Connecticut, both of which were incidents that resulted in severe damage to the ships and one crew fatality, and undetected underwater seamounts. Further study of this realm, he believes, could shed additional light on these UFO-UAP sightings. One incident to which Gallaudet points in particular is a July 19, 2019 encounter between the Independence-class littoral combat ship USS Omaha and a so-called transmedium UAP. In the incident, the crew of the Omaha sailing off the coast of San Diego used their ANCAX-2 electro-optical sensor to record a spherical UAP hovering just over the surface of the Pacific Ocean. The ANCAX-2 is a stabilized sensor turret built for maritime environments that includes a digital video camera, night vision camera, and laser rangefinder. The video is a recording of a screen showing the output of the ANCAX-2. The video appears to have been taken with the night vision camera, which uses imaging infrared to record objects in darkness. The object seemingly moves, tracked by the sensor operator, and then stops to hover. The object stops and hovers a short distance above the surface of the ocean. At the end, the object disappears, with sailors remarking that it made a splash as it entered the water. Meanwhile, one sailor off-camera radios the other ships in the area, the guided missile destroyers Pinckney, Kidd, and Rafael Peralta, asking for a MH-60 helicopter to be launched as soon as possible. The video was leaked to UFO investigator Jeremy Corbell Lockyer and was later verified as genuine by the Navy. A search of the Defense Visual Information Distribution Service, the Pentagon's website for releasing official photos and video, shows 3 of the warships in the encounter: Pinckney, Kidd, and Omaha, in formation in the Eastern Pacific 6 days later on July 25th. Gallaudet also references another sighting from 2013 spotted by U.S. Customs and Border Patrol personnel. The sighting, which took place near Aguadilla, Puerto Rico, was filmed using a similar imaging infrared camera. The video depicts another spherical object appearing to enter the water and then re-emerge without losing any speed. The retired admiral writes, "Over 3 minutes, the object appears to fly at speeds between 40 and 120 miles per hour, enter and exit the Atlantic Ocean without any significant deceleration, reach a maximum underwater velocity of 95 miles per hour, and at one point split into 2 parts before entering the water again." Other possible evidence cited by the Admiral includes an incident in 2022 in which the NOAA underwater exploration ship Okeanos Explorer discovered an unusual series of holes on the North Atlantic seafloor at a depth of 1.6 miles. The centimeter-sized holes were in an unusually straight line, and scientists are apparently at a loss to explain their origin. To scrutinize the merit of Gallaudet's statements, we must pause and take a closer look at Tim Gallaudet profile. This man entered the U.S. Navy in 1989 after attending the U.S. Naval Academy in Annapolis, Maryland. He served with a number of naval oceanography and meteorology commands, and was superintendent of the U.S. Naval Observatory. He assumed command of the Naval Meteorology and Oceanography Command in 2014 and served as oceanographer of the Navy from 2016 until retirement in 2017. After his Navy career, Gallaudet served for 2 years as acting administrator in charge of the National Oceanographic and Atmospheric Administration. Today, he sits on the advisory board for Americans for Safe Aerospace, which describes itself as a non-profit organization dedicated to aerospace safety and national security, with a focus on unidentified anomalous phenomena. ASA is led by Ryan Graves, a former U.S. naval aviator who reports having his own UAP sighting on active duty in 2014. In a 2023 op-ed published in The Hill, Gallaudet called UAPs the story of the century and clearly did not rule out an extraterrestrial cause for them. It's rare for a high-ranking U.S. military officer to directly address UAP issues even in retirement, and the incidents Gallaudet calls attention to are unusual, to say the least. What could possibly possess him to do such a thing? Could aliens be real? Could they be living among us? But if so, what's their goal? Well, let's accept that alien invasions of Earth are nothing new in sci-fi. One of the most famous examples is War of the Worlds, an H.G. Wells 19th century classic that was adapted into a Tom Cruise movie in 2005. In that film, aliens inexplicably begin bursting from underneath city pavement to incinerate humans. Or in the 1996 sci-fi comedy Mars Attacks, when the Martians first land on Earth, for a moment it appears all will be fine. Then their leader says, "We come in peace," as the music swells and a dove soars overhead. But seconds later, the Martian pulls out a laser gun and opens fire on a crowd of human onlookers. Yet another blockbuster alien invasion has begun. Of course, that's Hollywood. But the melodrama underscores one of humanity's most widely held fears: that if and when we do encounter extraterrestrial beings, they will wreak all kinds of havoc, much as they do in the movies. Even renowned physicist Stephen Hawking has said repeatedly that he's afraid of aliens wiping out the human race the way a human would wipe out a colony of ants. In 2015, Hawking co-launched an initiative called Breakthrough Listen, which will search for alien communication signals out in the cosmos, and eventually broadcast signals from the human race, with the goal of enabling communication across the universe. According to Hawking, we don't know much about aliens, but we know about humans. If you look at history, contact between humans and less intelligent organisms have often been disastrous from their point of view, and encounters between civilizations with advanced versus primitive technologies have gone badly for the less advanced. A civilization reading one of our messages could be billions of years ahead of us. If so, they will be vastly more powerful and may not see us as any more valuable than we see bacteria. By contrast to these arguments, many experts believe that if aliens exist, we probably don't matter to them at all. Either way, there's an obvious human-centric nature to the way we think of alien visitors, imagining them bothering to cross the vast distances of space just to, variously, buzz us in their mysterious flying saucers, make friends, abduct us, invade us, or harvest humans for food or energy. The truth is probably no one knows we're here, or cares. We're a young civilization in a very ordinary corner of the universe. Even advanced telescopes from far away would pick up no visible signs of life on Earth, just so-called techno-signatures of a planet that has water and oxygen. And for all the imagination that other civilizations would pick up our radio and television broadcasts, like Hitler's opening of the 1936 Olympics, one of the first major broadcasts, or the Super Bowl, the most powerful, frequent signal we broadcast into space. No human signal has journeyed even 100 light-years yet, a distance that covers only a sliver of the universe, even if the signal remains detectable across that distance. Even powerful telescopes or visiting craft from nearby alien civilizations could have looked at Earth not that long ago, and with even relatively advanced technology, and missed that we existed at all. Go back just 10,000 years or so, and human settlements would have been all but invisible to surveillance from space. So, as Stephen Hawking bluntly summarized it, the human race is just a chemical scum on a moderate-sized planet, orbiting around a very average star in the outer suburb of one among 100 billion galaxies. Elsewhere, Carl Sagan, the famous astronomer who was one of the strongest proponents of the search for extraterrestrial life in the 20th century, portrayed aliens as benign. But if aliens aren't interested in harvesting our lands or our bodies, why would they make contact? Well, a purer motive is curiosity. Anyway, if aliens did come to Earth, it would probably be as researchers, biologists, anthropologists, linguists, keen to understand the peculiar workings of life on Earth, to meet humanity and learn of our art, music, culture, languages, philosophies, and religions. That idea raises the question of whether our own human longing to reach for the stars may exist elsewhere, or even occur to other species. There is growing evidence that there are perhaps many marine environments across the universe, including not just planets, but moons with vast oceans far deeper than our own. Perhaps these ocean moons or ocean planets have hot, deep sea vents like Earth, the intense and wild environments where scientists increasingly believe might be one of the possible places that life began here. Extrapolate a bit from there, and there could be all manner of life-supporting marine planets filled with creatures equivalent to our highly intelligent whales and dolphins, creatures that surely pass the intelligent life test, and yet who have never glimpsed the Milky Way above and wondered about journeying to the stars. The desire to know our place in the universe is a core species yearning, even human. People have pondered the question for thousands of years. Indeed, hundreds of years before the birth of Christ, Greek philosophers such as Anaximander and Epicurus speculated that the cosmos is teeming with planets, many of which may support life. However, we couldn't move beyond mere speculation for a very long time, until we invented telescopes and developed a proper understanding of the scientific method. Humanity notched both of those milestones centuries ago, and scientists are now going great guns in the search for alien life. Well, going great guns is a bit of an overstatement, but we've made considerable progress, especially with SETI. SETI didn't really kick off until 1960. In that year, Cornell University astronomer Frank Drake used a radio telescope in West Virginia to listen for signals coming from the stars Tau Ceti and Epsilon Eridani. Called Project Ozma, this effort incorporated ideas from a seminal 1959 paper by Giuseppe Cocconi and Philip Morrison. Scientists have been scanning the heavens for techno-signatures ever since then. Initially, they focused almost exclusively on radio signals, but flashes of light are in play now as well. These are the targets of increasingly common optical SETI efforts. SETI scientists have to keep an open mind. After all, we don't know what sorts of messages an advanced alien civilization might beam out. So, astronomers in the field generally look for signals that appear weird and artificial, something coming from deep space that isn't produced by any known natural astrophysical phenomenon. It would also be nice if the signal recurs, so it can be studied repeatedly and in detail. One-offs can remain forever and frustratingly mysterious, as 1977's famous "wow" signal shows. In that case, a radio dish operated by the Ohio State University picked up something so intriguing that astronomer Jerry Eman wrote "wow" on the data printout. Researchers scoured that same patch of sky again and again, hoping to get another ping, but they never did. The SETI hunt, it should be noted, has historically been a shoestring operation. Finding enough money to keep the telescopes running has been a consistent problem. The U.S. Congress axed a planned NASA SETI project in 1993, and ever since then, extraterrestrial hunters have mostly had to turn to the private sector for cash. Without steady funding, progress was slow for several years. But private money has flowed more freely into the SETI field recently. Most of it comes from one man, tech billionaire Yuri Milner. Passionate about the search for alien life, Milner established an ambitious program in 2015 called Breakthrough Initiatives to seek out extraterrestrials. Among the projects under the Breakthrough umbrella are the $100 million Breakthrough Listen SETI campaign and the $100 million Breakthrough Starshot, which aims to develop the technology required to send tiny robotic probes to nearby exoplanet systems at about 20% the speed of light. There's also Breakthrough Message, which aims to both help humanity craft the best possible message to send out into the cosmos and encourage debate and conversation about SETI in general. And there is considerable debate within the scientific community about SETI. Some people, including the late physicist Stephen Hawking, have argued that it's unwise to advertise our presence to aliens whose nature and intent are complete mysteries to us. These creatures may pillage our planet after picking up our ping, after all. But other researchers think any creatures advanced enough to travel to Earth to enslave or eat us would already know we're here anyway. Breakthrough Message pledges not to actually broadcast any SETI signals until this debate has played itself out. But humanity has already beamed out messages on multiple occasions, most famously in 1974 with the Arecibo message. And those are just the intentional, directed missives. We're leaking radio signals in all directions at all times, providing cosmic breadcrumbs for anyone close enough to find them. Around the same time that SETI was getting off the ground, planetary scientists began getting their first good looks at alien worlds. In 1964, Mariner 4 flew by Mars, returning the first up-close images of the red planet. Those photos revealed a dry, heavily cratered, and seemingly desolate world, forcing many scientists to recalibrate previously optimistic notions of Mars' habitability. But the optimists got some good news in 1969 after Mariner 9 arrived in orbit around Mars, becoming the first spacecraft to circle another planet in the process. This probe spotted river channels and other evidence of past liquid water activity on the Martian surface. These discoveries helped spur NASA to develop two ambitious life-hunting Mars missions, Viking 1 and 2, which launched a few weeks apart in 1975. The identical Viking landers each carried 4 biology experiments which hunted for signs of microbial life in the red dirt. One of those experiments, called Labeled Release, returned data consistent with evidence of microbial life. Indeed, Labeled Release principal investigator Gil Levin argued that the Vikings found evidence of Mars life. However, most scientists who studied the data disagreed with Levin, determining that the data could be explained by abiotic, non-life-based, chemical reactions. The Viking results taught NASA and astrobiologists some valuable lessons, chiefly that they didn't know enough about Mars to mount a proper life hunt there. So, the space agency eventually embarked on a long-term follow-the-water exploration strategy, seeking to learn more about ancient environmental conditions on the red planet and how they changed over time. This strategy gave us many prominent Mars missions over the past few decades, including the orbiters Mars Odyssey, Mars Reconnaissance Orbiter, and Mars Atmosphere and Volatile Evolution, the rovers Spirit, Opportunity and Curiosity, and the Phoenix Lander. These robotic explorers did their jobs well, finding lots of evidence that ancient Mars was quite wet and helping scientists better understand why, how, and when the red planet transitioned to the frigid desert world it is today. Curiosity has taken this work the furthest, finding that its landing site, the 96-mile-wide, 154 kilometers Gale Crater, hosted a long-lived lake and stream system billions of years ago that could have supported Earth-like life. Meanwhile, some scientists continued the hunt for Mars life, focusing on aliens that may have fallen fortuitously to Earth. Over the eons, billions of red planet rocks have made their way here, after being blasted into space by powerful asteroid or comet impacts. A lot of Earth material has ended up on Mars as well, but the ledger is decidedly unbalanced. The sun's powerful gravity pulls more stuff inward, toward Earth. This extensive rock swapping, by the way, has led some scientists to postulate that life actually arose first on Mars, then made its way to Earth later. In 1996, researchers announced that they'd found potential signs of life in one such Mars meteorite, known as Allen Hills 84001. It was a very big deal. The result was published in the prestigious journal Science, and President Bill Clinton held a press conference about the news on the White House lawn. The Allen Hills 84001 story ended up going down a Viking path. Other scientists picked at the claim, and a consensus emerged that the meteorite evidence was ambiguous at best. But, like Levin, the Allen Hills 84001 team held firm in its findings and continues to do so today. NASA and the broader exploration community weren't focused solely on Mars for all these years, of course. The Cassini-Huygens mission, which ended in September 2017, transformed scientists' understanding of the Saturn system and our solar system's potential to host alien life. That mission found that Titan, Saturn's largest moon, has a hydrocarbon-based weather system, and that the frigid moon's surface harbors lakes and seas of liquid ethane and methane. Life could swim around in these seas, though it would have to be very different than the life we know here on Earth. And the Cassini orbiter spotted geysers blasting from the south pole of another Saturn moon, the ice-covered Enceladus. This discovery and other Cassini observations revealed that Enceladus harbors a big ocean of salty liquid water beneath its shell. The geysers produce a huge plume of water ice and other material, a cloud so substantial that it creates Saturn's E-ring. Cassini flew through this plume on multiple occasions, gathering samples that scientists analyzed for clues about the moon's subsurface environment. The researchers found carbon-containing organic compounds and free hydrogen, the latter of which suggests the existence of a hydrothermal system in Enceladus's buried ocean. Undersea hydrothermal vents are one popularly invoked environment for the origin of life on Earth. Buried oceans are relatively common in the outer solar system. Scientists have come to realize multiple ice-covered Jupiter moons seem to have these oceans: Ganymede, Callisto, and most intriguingly, Europa. Europa's huge subsurface sea seems to be in contact with the moon's rocky core, like the ocean of Enceladus is, making possible a range of complex chemical reactions that could theoretically have led to life. Titan seems to have a buried ocean of salty water as well, meaning the moon likely has two very different, potentially habitable environments. Observations by NASA's New Horizons spacecraft indicate that liquid water may slosh beneath Pluto's surface too, and the list goes on. Indeed, the abundance of water worlds in the outer solar system suggests that looking for Earth 2.0 may not be the best life-hunting strategy. Most of the habitable real estate in the cosmos may be buried under ice. These revelations about our celestial backyard have come in parallel with big news about the cosmos at large. Over the past decade or so, we have learned that our Milky Way galaxy is teeming with potentially life-supporting worlds, as Anaximander and Epicurus surmised so many centuries ago. Much of this knowledge comes courtesy of NASA's pioneering Kepler Space Telescope, which operated from 2009 through November 2018. Kepler is responsible for nearly 2/3 of the 4,400 confirmed exoplanet discoveries to date, and mission data reveal that planets outnumber stars in our galaxy. Many of those planets might bear more than a passing resemblance to Earth. Kepler found that at least 20% of Milky Way stars probably host rocky planets in their habitable zones, the just right range of orbital distances where liquid water could persist on a world's surface. Some of these potentially habitable worlds are just a stone's throw away in the cosmic scheme of things. For example, the nearest star to the Sun, Proxima Centauri, which is about 4.2 light-years away from us, hosts a roughly Earth-sized planet in the habitable zone. This world, called Proxima b, is a prime breakthrough starshot target. And the TRAPPIST-1 system, which lies 39 light-years from us, boasts 7 rocky worlds, 3 of which may be capable of supporting life as we know it. However, both Proxima Centauri and TRAPPIST-1 are red dwarfs, like 70% of the Milky Way's stellar population. Red dwarfs are small but very active stars, and their intense flaring may severely dampen their planet's habitability. Kepler's legacy is being carried on by other exoplanet missions, such as NASA's Transiting Exoplanet Survey satellite, TESS, which is expected to find thousands more alien worlds circling nearby stars, ESA's CHEOPS probe, which aims to characterize some of these neighboring worlds, and the most powerful observatory ever launched, James Webb Space Telescope. The avalanche of exoplanet discoveries, as well as finds much closer to home, have brought astrobiology from the scientific fringe firmly into the mainstream. NASA is openly prioritizing the search for alien life these days, as some current and coming missions show. For example, in July 2020, the agency launched the Perseverance rover, which landed in February 2021 to hunt for signs of ancient Mars life and collect samples for eventual return to Earth. Finding evidence of long-dead microbes is expected to be a very tricky task, one ideally carried out by teams of scientists in well-equipped labs studying pristine pieces of Mars specifically selected for their life-preserving potential. In 2024, NASA's Europa Clipper mission launched toward the Jupiter system. Clipper will orbit the gas giant but make dozens of flybys of Europa, characterizing the Moon's subsurface ocean and scouting out good touchdown sites for a future life-hunting lander, among other tasks. And in 2028, NASA plans to launch Dragonfly, a probe that will fly through Titan's thick, smoggy skies. Dragonfly's main goals involve investigating the complex chemistry that could set the stage for life's emergence and assessing Titan's habitability, but the rotorcraft will also search for biosignatures. The agency will also soon start hunting for aliens much farther afield. In January 2023, Dr. Mark Clampin, the director of NASA's Astrophysics Division, told a meeting of the American Astronomical Society that the successor to Webb would be called the Habitable Worlds Observatory, or HWO for short. Although it's still very early days in the HWO's design process, even the name is only a working title. A couple of things have already become clear about the project. HWO will be as large as Webb, but will observe at the same wavelengths as Hubble. This means that the HWO's mirror should be around 19 MAFT in diameter, and instead of infrared, it should work at optical and ultraviolet wavelengths. Like Webb, it will be situated at Lagrange point 2, the gravitational sweet spot, 932,000 miles from Earth. And, like Hubble, it will be designed for periodic upgrading, although these servicing missions will be undertaken by robotic spacecraft instead of astronauts. The concept for this mission comes from an amalgamation of 2 others that NASA studied in the late 2010s. The first was called LUVOIR, the Large Ultraviolet, Optical, and Infrared Surveyor. As the name suggests, it would cover a large range of wavelengths centered on visible light and be a general astrophysical observatory, as Webb and Hubble were. 2 conceptual designs were developed for LUVOIR, one with an 8 mm diameter, 26 ft mirror, and one with a 49 ft diameter mirror. Both designs would be made of hexagonal mirror segments, like Webb. The second concept that NASA investigated was the Habitable Exoplanet Imaging Mission, or HABEX. This was envisaged to be a space telescope with a 13th diameter mirror. Although optimized for the investigation of exoplanet atmospheres, it could also extend many of the investigations that Hubble had pioneered. Both projects were submitted to the 2020 Astronomy and Astrophysics Decadal Survey, run by the National Academy of Sciences in the US, along with 2 other mission concepts, an X-ray telescope called LYNX and a far-infrared telescope called Origins. After due deliberation, the survey recommended NASA conduct a program of technological development for 5 years to ready itself to build all of these missions, with the caveat that LUVOIR and HABEX be merged into a single mission with a 19-ft diameter telescope. This is the mission now called HWO, that Clampin announced at the American Astronomical Society, and it will be the first mission to be worked on to completion of the technology development. In addition, some of this alien searching will continue to occur in Earth-based studies, and it won't just involve inspection of Mars meteorites. There's an ongoing search for a shadow biosphere on our planet, an entire tree of life separate from the one that includes bacteria, bats, birds, and everything else we currently recognize as alive. This pursuit isn't so crazy if you think about it. After all, life appeared on Earth about 4 billion years ago, very quickly considering that our planet formed just 4.5 billion years ago and remained hot and inhospitable for a long time thereafter. So, life's emergence doesn't seem miraculous, which, in turn, implies that it could have happened here more than once. Given the incredible abundance of potentially habitable real estate, and that's just for Earth-like life, to say nothing of the environments that could support strange life of various types. Why haven't we found extraterrestrial yet? Nobel Prize-winning physicist Enrico Fermi famously posed this question in 1950, specifically referring to intelligent aliens. 7 decades later, the answer to the Fermi paradox remains elusive. However, answers is probably a better formulation, because multiple factors are probably working together to keep us from finding intelligent aliens. Among the foremost is the vastness of space, which makes it difficult for two civilizations to touch base. Consider, Proxima b is just 4.2 light-years away, in a galaxy 100,000 light-years wide. But 4.2 light-years is about 26 trillion miles, 42 trillion kilometers, an expanse that would take humanity's current spacecraft tens of thousands of years to cross. Contact with intelligent aliens would require temporal and temperamental alignments as well. Their civilization would have to rise in sync with ours, no mean feat, in a universe that's 13.82 billion years old. An extraterrestrial would have to want to reach out. That's no given either. There are many reasons some aliens may want to keep quiet, as the medi-pessimists have pointed out. Or maybe intelligence is rare throughout the cosmos, even if life isn't. Earth has been inhabited for about 4 billion years after all, but we've been sending out radio waves for just a century or so and launching spacecraft only since 1957. And it's tough to find faraway microbes, which presumably have not yet invented the radio. Our technological youth may be the biggest factor of all. We've just begun the search for our cosmic neighbors after all, and that search has mostly been halting and haphazard, conducted by small teams of dedicated researchers who've had to scrounge money to keep the lights on. But that's changing, as the exciting new missions and instruments currently in development show. So we may start getting some answers very soon. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.